Good morning, dear students. So, in this video, we discuss about what is vector product, what is the vector product, or we can say what is cross product. Okay, what is vector product? And vector product is also called cross product. So, we can say cross product also. Okay, so if it is written A cross B, suppose if it is written A vector cross B vector, then A cross B is called AB sine theta into n cap. Into n cap. What is n cap? Unit vector perpendicular to both A vector and B vector. A and B both perpendicular vector is called n cap. And what is the value of n cap? That is 1. So the formula is A cross B, all of you write A cross B equal to AB sine theta into n cap. Okay. Vector product gives vector quantity. So it is also written as cross product or vector product. Suppose if we want to calculate the torque about any point. So torque formula we can represent tau. So tau formula is R vector cross F vector. Okay, tau vector equal to R vector cross F vector, where R is the position vector and F is the force. Okay, so how we calculate A cross B? What is the properties of cross product? So first we learn what is the properties of vector product. So write a heading: properties of cross product. Properties of cross product. Okay, so write first property. First property, that is the vector product is not commutative. The vector product is not commutative. What is meaning by commutative? Commutative means A cross B is not equal to B cross A. A cross B is not equal to B cross A. Not equal to, that means this. So A cross B equal to no, is not equal to B cross A. Now the second property. Second property is this, that vector product is distributive. The vector product is distributive. Distributive means if we write A cross B plus C. For an example, if we write A vector cross B vector plus C vector. Okay, so we can say that it is equal to A cross B plus A cross C. A cross B plus A cross C. Okay. Now the third property. All of you write third property. That is the magnitude of vector product. The magnitude of vector product vector product of two mutually perpendicular vectors. Mutually perpendicular vectors is equal to the product of is equal to the product of the magnitude of these two vectors. The magnitude of these vectors. Okay. So what is the meaning of this line? This statement that the magnitude of two vector product, the magnitude of vector product of two mutually perpendicular vectors. Suppose A vector and B vector. If it is written mod of A vector cross B vector, then it is equal to A into B. When if A vector is perpendicular to B vector, it is true when A vector is perpendicular to B vector, because if A and B are perpendicular, then theta equal to 90 degree, and we all know that sine 90 equal to 1. So this relation holds that A cross B equal to A into B. Now the fourth property. All the three properties are clear to all of you. Now the fourth property. The vector product of two parallel vectors. Okay, so the vector product of two parallel vectors is a null vector. The vector product of two parallel vector is a null vector. So what is the meaning of two parallel vector? That means theta equal to 0 degree. And if we want to calculate A cross B, then it is written A B sine theta into n cap. And what is the value of theta? That is 0. So A into B sine 0 into n cap. So it is written 0. So A cross B equal to 0 vector. Okay, fourth property is clear to all of you. Good. Now the fifth property. Fifth property, that is if we want to calculate vector product. Fifth property, the vector product of a vector by itself is a null vector. Is a null vector. Suppose if we want to calculate A cross A, so tell me what is the value of A cross A. If we write A cross A, so what is the angle between A and A? That is 0. So again we write A into A sine 0 into n cap. So sine 0 is 0. So A cross A is written as 0 vector. Okay. So A cross A is written as 0 vector. Okay. Six properties clear to all of you. So this is the main property which is based on the properties of cross product. Now the sixth property. What is sixth property? That is the vector product of two orthogonal vectors. the vector product of two orthogonal vectors gives following relation. Gives following relations. What is the relation? I will explain you. Suppose if it is written, what is orthogonal vector? You all know that this is y-axis, this is the x-axis, and this is z-axis. Okay. So it is written I cap, j cap, and k cap. Y-axis is written as j cap. This is written I cap, and this is written k cap. So if we write I cross j equal to, we get k cap, j cross k equal to I cap, and k cross I, it is equal to j cap. So all of you write these property. I cross j equal to k cap, j cross k equal to I cap, and k cross I equal to j cap. Okay, how it is done? So if suppose if we take a circle and we write ijk in this format, we write ijk, suppose I is here, j is in this side, and k cap is in this side, and in the same way I cap, j cap, and k cap. Okay, so if we move anti-clockwise, so I cross j, if we move anti-clockwise, so I cross j equal to k, and if we move j cross k, so what comes after in a circular path after j and k? J and k, what is come? That is I. So j cross k equal to I cap, and k cross I, equal to j cap. And if we move clockwise direction, so that is I cross k. So in clockwise direction we get negative. I cross k equal to minus j, k cross j equal to minus I, and j cross I equal to minus k. Okay, so these properties are clear to all of you. Okay, goodbye, take care all of you.